Hello. So today we will continue with the Newton's second law and we will learn more about the friction force. Before I talk about the friction force, I just want to remind you quickly that so far we know about three important forces that act upon objects. One of them is the weight. And we said whenever there is an object that has a mass m, then there is a weight force exerted on it. Some people call it force of gravity. And the magnitude of the weight is m times g. The direction is perpendicular to the ground, okay? It's always perpendicular to the ground. It's always like this, okay? It never has any angles. It's always like this. Then we said if an object is put on a surface, then this surface exerts a force on it, and it's called the normal force, And the direction of the normal force, it depends on the surface. If the surface is horizontal, then the normal force is just perpendicular to it in this way. However, if the surface is making an angle different than 0 with the x-axis, then the normal will also be making an angle, okay? Most importantly is that it will be perpendicular to the surface. So in this case, for example, the normal will be in this case, in this way, but the weight will be in this way, okay? So they are not always one up, one down like this. Another force we talked about last week, that was the tension force. And we said whenever there is a rope, whenever there is a rubber band, whenever there is a spring, then there is a tension force exerted on the object. And in particular, in the case of a spring, we remember together Hooke's law, which says if I compress a mass against a spring, the spring will exert a restoring force, a tension restoring force. That is, it wants to go back to its original, to its relaxed length. And this tension force is equal to some spring constant, K, times delta L, and that's the compression of the spring. Same way, if I elongate the spring, it will not be happy in that position. Once I remove my hand, it will go back to the relaxed form, okay, to the relaxed shape. So also in this case, Hooke's law, tension is equal K times delta L, where delta L in this case is the elongation. How is the direction? That's the magnitude, and the direction of the friction tension force, sorry, is always along the spring. It's always, there is a string, it's along the string. So for example, if I have a string this way and there is some mass attached to it at the end, then the tension force is upward, okay? It's along the string. However, in the case of the spring, it depends. If it's compressed, then the tension will be in the opposite way of the compression. If it's elongated, then the tension force will be in the opposite case of the elongation, okay? Today, we will talk more about friction force. So when do we observe friction? Here is a very heavy object where this man is holding a rope, attaching to it a rope and trying to pull it in order to move it. But he's exerting lots of force and still he's unable to pull it. So what are the forces acting on this object? First force is the weight. It's downward. There is the normal upward, but this is not what we are interested in here. We are interested in here that he's actually exerting a tension force over here, but the object is not moving. Why is this? Because there is a friction force pulling in the other direction, okay? So he's pulling in this way, but there is a friction force pulling in the other direction, and it's against his force. Okay, where do we observe this friction force? A frog resting on a plane, resting on a slope. How come it's resting? Why it's not falling down, for example? It's because there is a tension force okay, it should go downward, right? It should fall down the slope, but it's not. It's because there is a friction force upward. This rock, the lady is pushing it, it's pushing it, but the rock is not moving. This is because there is a friction force in the opposite direction. This girl is on a sled and the sled is moving down the snow. Why doesn't she go forever? Why doesn't she stop after some time? Because there is a friction in the opposite direction. The same thing with a ball. Why is it in a soccer game or football game, when they shoot a ball, it stops after some time? It moves, 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 but it will slow down and stops because there is a friction force in the opposite direction. Okay, so objects do not move. It means there is a force not allowing them to move. And this force is called friction force. Friction force. Okay, the direction of it is always, it's written down here, the direction of it is opposite to the motion that it is supposed to move. Okay, if it's moving, then it's opposite to motion. So there is a force opposing the movement. Now, if the object is not moving at all, like in the case of the frog or the case of the rock, then we call the friction static friction. Okay, static friction. Static means not moving. If the ball is moving, or in this case, the girl is moving and there is friction, it's called kinetic friction, that is moving, okay? It doesn't really matter whether it's static or kinetic. All I want you to remember is that it is called friction. And the magnitude of the friction, that is, if I want to calculate the friction, there is this mu, which is a coefficient of friction. It will be given in the question, or you will be supposed to calculate it. So they will tell you there is this ball rolling on a rough surface of coefficient of friction mu equal to, for example, 0.1, calculate the friction force or something like that. And it is multiplied by the normal force. Okay, so I want you to remember, if an object, I'm applying lots of force on it and it's not moving, it implies there is not something not allowing it to move, and this is friction force. If an object was given some push and then it stops after some time, it means there is an object opposing its moving and it stopped it, and this force is also the friction. To calculate the friction, we multiply this coefficient of kinetic of friction by the normal force. The direction of friction is always against the motion. So let's now solve one of the exercises from your booklet to understand it better. So we have a block of mass M. They're giving me the mass M. So from this mass, I can calculate, for example, the weight later. Is pulled up an inclined plane with a force F equal 32 Newton. So they're giving me this force. Its magnitude is 32 Newton, parallel to the plane. The inclined plane makes an angle theta equal 30 degrees with the horizontal. So this is very similar to the problem we solved last week during the live session until now. The first part, draw a free body diagram for the block if the inclined plane is frictionless. So we will start with the case one, it's frictionless, okay? They want us to draw the free body diagram. So let's remember together how we draw free body diagram, okay? I start by drawing the surface because there is a surface, okay? Then there is a ground. I also draw the ground because I need to calculate to draw the weight later. So this is my surface and the ground. Now I put, instead of this big block, I put a small tiny sphere, and now I put all the forces on it. Okay, so let's do this in a different color. The forces are, the very first force, you always remember that the first force is the weight, and it should be perpendicular to the ground. So here it's perpendicular to the ground. Then it has a surface, so there is a normal force perpendicular to the surface. Okay. Now there is this F force also upward along the incline. So I will draw it like this. It's up on the incline. It's frictionless, so there is no other force. Okay, there is no rope, so there is no tension. Okay, there is no friction, so there is no friction. Let's just put the names of these forces. So here we designate it's N, designated by N. This is here force F, and this is here force W, and they are forces, so vectors, so I have to put this vector sign everywhere. Okay, okay. Now, when I want to, now part B, find the acceleration of the block if the incline is frictionless. Okay, in order to get the acceleration, I have to apply one of the two Newton's second law. Which one of the two equations has acceleration in it? The first one or the second one? The first one. So I have to apply Newton's, this is part B. I have to apply, let's write in red, summation of Fx is equal to ma. Before I continue, I have to, since I draw already, before I can apply Newton's second law, remember, first I draw the free body diagram, then I choose x-axis along the line of motion, okay? So if this object, how do you think it will move? There is a force pulling it upward. It means it will move this way. So this will be my x-axis. Then I draw y-axis perpendicular to it and counterclockwise. So if this is x-axis, I go counterclockwise, and I draw my y-axis. Okay, so this is here x-axis. This is here y-axis. Okay. Okay. If I look here, I will find that my F is on the x-axis, my N is on the y-axis. So, for example, vector F has two components, right? One of them is all of F, and the other one is 0. Because it has no y component, it's all on the x-axis. Vector N, it has also two components. The x component is 0 because it is all on the y-axis, and the y component of N. However, if I come to W, it is not on the x-axis, not on the y-axis. To reach it, I have to go first along the x-axis. Let's choose a different color. First, I have to go along the x-axis, okay, until I can see the tip of the vector. And then I go the tip of the vector, sorry, somewhere here. And then I go along the y-axis, okay? So this is Wx. And this is W1. Okay? They are giving me this piece of information that this angle is equal to 30, right? This angle here is equal to 30 degrees. Now we look at triangle O because I have to calculate Wx and Wy. OAB. Okay, this is triangle OAB. In triangle OAB, I know this angle is 30. I know this angle A is 90. So angle O is how much? It's 60. Okay, so this angle here is 60. it's 60. I don't know if I can fit it without ruining. Doesn't look good. So just put it in your mind that if this angle is 30, then this angle is 60. This angle over here. Okay. So now, WX is the adjacent or the opposite of angle 60? It's the adjacent. So WX, I just write over here. WX is equal to, let's do it in the same color. WX is equal to W cosine of 60. I just pay attention that WX is opposite to the x-axis. It's in the negative direction. So I should put a negative sign here. Now, instead of W, I will put M times G, which is 5.8 times 10, and that's 58. Okay. Cosine 60, and this gives me minus 29. Okay, so this is WX. WY, if the first one is cosine, the other one will be sine. So minus 58 sine angle 60, and this is minus 50.22 Newton. Why is it minus? Because also y-axis is upward and the direction of WY is downward. So now I know the WX and WY. Now I come to the summation of Fx equal to MA. Okay, what are my forces? I have an X. I have three forces. So I have an X plus Fx plus Wx is equal to mass times acceleration, and X is 0 because it's along the y-axis. Fx over here, it's all of F, plus Wx, we have just calculated it, it's minus 29. This is equal mass 5.8 times acceleration. So F, I know it's 32, it's given, right? F is 32, it's given. 32 minus 29 equal to 3. So acceleration equal to 3 divided by 5.8. Acceleration is equal to 0.51 meter per second square. Okay, so this is when the inclined plane is frictionless. This is part B. Okay, in the solution, if you look at lecture 21 that I attached as a PDF file, you will see that I didn't use this angle over here, which is 60. I used this angle over here. Let me just show you which one. I used this one over here. Why? Because this triangle, look at it. Let's call this here C. Okay. If you look at triangle OCA, angle O is 60, angle C is 90, so angle A is 30. So when I calculated WX and WY, I used that WX is opposite to angle 30, so it is W sine angle 30, but it will give you the same answer. And WY will be minus 58 cosine angle 30, and it will give you the same answer, okay? So I solved it that way because I know just to show you that I can either take angle O here from triangle OAB. Okay, so angle O in triangle OAB is equal to 60. So you can either use this piece of information in triangle OAB, and then you take WX and WY to be cosine 60 and sine 60, or you take angle A in triangle OCA, it's equal to 30. In this case, WX will be opposite to angle 30, so it will be W sine 30. and WY will be the adjacent of angle 30, and it will be cosine, W cosine 30. Okay, so I solved it in this way just to show you that you can choose either angle. You are free. Fine. Part C. Part C. Find the acceleration. So now also I have to find the acceleration, but this time, if the coefficient of kinetic friction between the block and the incline equals 0.1. So this is mu. Okay, this is, let me try to draw it. This is mu. Okay, this is a mu. It's equal to 0.1. So now there is friction. Now I have to repeat the whole thing. I already draw force F, force M, force W. Now I have to add that I have a new force. And in which direction will the new force be? If the object is moving upward, the friction will be in the opposite direction. Okay, I'll draw it in blue just to show that now we have an additional force. It's in the opposite direction. So now this is force friction. We designated by F. Okay, and it's a force, so it has a vector sign on top of it. Okay, now we need to calculate the friction again. So to calculate the friction again, the acceleration again. So also I have to use Newton's second law, the first one, which is summation of Fx is equal to mass times the new acceleration. Let's call it A2. Okay, the new acceleration. Now, what forces do I have along the x-axis? I have an x, I have Fx now, I have the big Fx, and I have Wx. This is equal m times A2. And x is 0, we know it already. Friction is all of F because it's all on the x-axis, right? But it's in the opposite direction, so it's minus F plus F. Wx is minus 29 equal to, of course, F I know now it's 32, it's given 32 minus 29 is equal to 5.8 times A2. Okay. Now, what do I know about the friction force? Do I know how much it is? 32 minus 29 is 3. I can put it to get rid of it. Minus F. What do I know about F? I know that it is mu. Okay, I will put mu times normal force. This is the friction force. This is equal to 5.8 times A2 that I have to calculate. So mu, I know it. I will put 0.1 here. So this is easy, but I don't know how much is the normal force. Now, can I calculate the normal force? Can I find a way to calculate the normal force? I look at it, I find that it is all on the y-axis. The normal force is on the y-axis. So to calculate, I can calculate normal force by using summation of Fy equal to 0 because it's on the y-axis. So just before I continue, this force F, it is minus F0, right? Okay, so this friction force is minus F0. Now, I have to summation of Fy equal to 0. So let's put, I have Ny plus Fy plus Fy. Let's put them in the same order so you don't get confused. Plus wy is equal to 0. Ny is all of n. Fy is 0 because it's on the x-axis. Fy is 0. Big Fy is 0 because it's on the x-axis. Wy, we calculated it. It's minus 50.22. This is equal to 0, implies n is equal 50.22 Newton. Okay. So now I plug this value in this equation. Okay. So I get, let's do it here. I get 3 minus 0.1 times 50.22 equal 5.882. 50 times 20 to 0.1 times 50.22 is 5.022. This is equal to 5.882. 3 minus 5.022 is equal minus 2.022. This is equal to 5.882, and you get A2 is equal to minus 0.35 meter per second square. Okay. What does it mean? What does it mean that I get the acceleration negative? Okay. What does it mean? So there is this mass. I'm applying a force upward. Okay. And the acceleration is negative. If the force is along the x-axis upward in this way, okay, it means the object, it is moving in this way, but its speed is the velocity is decreasing, or its speed is decreasing. Because, why is this? Because there is a force pulling in the other direction. Okay, so this is the lecture for today. We remember together how to draw free body diagram if we have an inclined plane. This is one of the difficult ideas that may come on an exam. This is why I'm trying to solve problems with inclined plane as much as possible, so as you get trained to it. Second, we learned how to calculate friction, and what is friction, and what is the direction of friction. Okay, if you just continue the lecture, you will find the full solution on the coming slides. Okay, and I will be uploading this for sure on Google Classroom. If you have any questions regarding this lecture or any other lecture, you know what to do. You just either make a comment on the lecture on Google Classroom, or send me an email, and I will make sure I reply to your questions during the live sessions on Tuesdays and Thursdays. Okay, for now, that's it, and have a good day.